Good morning, everyone. My name is Ryan Brooks, and I'm here to give a high-level overview about how to create and scale meaningful performance tests in CI. This talk was inspired by many of the common questions and concerns that we tend to see at my company, Emerge Tools, when introducing our clients to the complicated world of performance testing. I've learned that testing performance at scale is a very complicated endeavor, and hopefully this presentation can give some guidance and lower the barrier of entry to performance testing across an organization. So a bit about me before we get started. I'm the Android lead at Emerge Tools, where I've built out our entire Android suite of tools to both measure app size and runtime performance. I've been at Emerge for a little bit over a year now, and it's been an awesome ride so far. Before Emerge, I worked at Airbnb for about 3 years. I worked on server-driven UI, known as the Ghost platform. If some of you guys have seen the articles that Airbnb has posted on it. Working on GP, we encountered many performance issues at scale, especially when moving to server-driven UI, which introduced me to the importance of performance at scale. So let's look at a quick agenda for what we're going to talk about today. We'll first establish a base and discuss what mobile performance even is, to give us a platform where we can go off of to actually determine what's worth testing before production. As a little bit of a spoiler alert, not everything is something that we necessarily want or realistically even can performance test. After we establish that framework, we'll take a high-level look at the different tools that we have at our disposal on Android to test those metrics in CI. And to bring it all together, we'll talk about some of the strategies that we can use to scale those performance tests across an organization, focusing on the different trade-offs and the levers that you guys can adjust for your org. So let's go ahead and hop in. So before we talk about how to measure, test, and scale performance in CI, it's important to lay a groundwork for what mobile performance really is, so that we can know what metrics we can measure, and more importantly, why we should measure those metrics. So as a mobile engineer, performance is oftentimes highly coordinated with the business cases of our apps. So for your favorite news reader app, in this case Hacker News, the time it takes to launch into the app and to start browsing is an incredibly important metric. Too long, and users might leave before ever they engage with any content. For a shopping app like Walmart here, getting to the checkout screen needs to be as fast as possible. Slow performance at any stage, and users might exit before they ever complete the checkout phase, which obviously has a massive business metric impact. And for a streaming app like YouTube, the time it takes to search for videos, load, and start playing needs to be as fast as possible. Well, business cases highly drive the performance metrics. Let's take the universal case from our previous slide, being startup time. I'm going to use Hacker News here as an example of a standard startup flow that almost all app developers will relate to. A surprisingly large amount of work takes place in the about 4-second launch time of this app from the last screen. We usually like to think of these interactions as one overall macro metric that we want to measure, in this case being startup time, being the tap of the icon to the point at which the stories are rendered on the screen that you see right here. But as I mentioned, this simple few-second interaction is made up of lots of smaller interactions that make up to our overall startup metric that we want to measure. So let's break it down into all the smaller pieces that make up that path. During this startup path, a ton of tiny things occur. Process starts. Your application is created. Dex is loaded. Just-in-time compilation might occur. Content providers are initialized, SDKs are initialized, dependencies are instantiated, view models are created, so on, so on. But when it comes to performance testing, it's not realistic to test all of these things in silo. So let's separate these metrics into those that are in our control and those that are not in our control as mobile developers. So I like to think of things shipped with the app to be mobile specific. Things that are in the actual Dex that's downloaded by users as part of your application. This essentially includes most of the metrics from the previous slide, like SDK initializations and rendering UI, business logic. Things that are out of our control though, like network requests and communication with other processes, are still important to us. If a network request is slow to load, it's still a bad user experience, obviously. But that's not necessarily something that we want to focus on testing as mobile engineers. So taking from all of this, it's important to test things that are in our control as part of our mobile performance suite. and leaving things that are out of our direct control, like network latency, round-trip time, communicating with different processes, and to be tracked in production rather than testing, which we won't discuss about tracking today. And in many circumstances, we primarily just want to test a macro measure like we talked about earlier, just being startup, rather than separately testing how long it takes to initialize one of those SDKs or how long it takes to initialize a content provider in our app. These micro measures are definitely worth testing, but creating, maintaining, and updating these micro tests are cumbersome and will take a non-trivial amount of work. And because of that, it's important to measure the impact of our testing changes. And to be as impactful as possible, we're going to focus today on primarily testing these macro measures. Things like user flows or longer like user stories. One thing I want to touch on that I mentioned briefly too before we get much further in is we're focusing on testing performance before it makes it into production. Testing is not a replacement for tracking performance in production. Rather, it's a complement to it. Pre-production testing will never be able to give us the full picture of what our users are experiencing in production, simply due to just the amount of data, the amount of edge cases, the different devices our users might be using. This, of course, is not saying that testing in prod is a bad idea. In fact, there'd be no point to this talk about saying that. But we can test for measures that catch large regressions before they make it into production, but we still need production data to paint the full picture for us. So now that we've gone over what we deem to be what mobile performance is and what we'll focus on today, I'm going to introduce a framework that I like to follow when I'm determining what metrics that I want to test for different flows in my app. And it's important to hone in on some shared characteristics we want these metrics to follow and why we want them to have those characteristics. And the three characteristics that I like to classify good testable performance measures having is that they're controllable, they are reproducible, and that they are impactful. And so let's get into what each of these means as it pertains to performance testing. So we touched on it earlier, but the first criteria for a good performance metric is that it's controllable. To explain this, let's look a bit more at that same startup example that we talked about earlier. So we already discussed that network latency might not be like the best specific thing to test for. These two requests that you see in the video on the left and the right were fired about 15 minutes apart. This was just a startup test that I had written. But the one on the right was a good 1.5 seconds slower than the one on the left. I didn't change anything about this. That just is how it happened to be. If our startup time test was running to measure, do we have a regression in startup time, we might actually see that it got 1.5 seconds worse, which is not true. That in reality, that 1.5 second regression was just caused by things outside of our control, like the round-trip time that this request took to hit our servers, or it could have just taken a completely different path on that way than the one on the left did. And so that's why it's important to be able to control the metrics that occur during our performance test, so that we can ensure that if there truly was a regression introduced in the app's code, we can know if it was a real regression rather than just noise in the system from something that was outside of our control. The second criteria for a good performance metric to record is that it's reproducible. So following that Walmart example that I showed you guys earlier, one of our core business metrics at Walmart might be the time to hit the buy now modal. Users expect a fast and snappy checkout performance when they want to go and purchase an item. And any regression in that performance could have a huge business metric impact. Users might leave if it takes a second longer, and at scale, those regressions compound and have massive effects on our overall business metrics. So testing this flow might sound like a good idea, to write a test for tapping the Buy Now button and seeing how long it takes to load a checkout screen like this. But that's not necessarily the best test in the world that we want to test. This test is actually relatively non-deterministic, and we'll see that in the next slide, without workarounds, of course. The top product that we clicked in this example is a Google Pixel 6 case, which will launch a page and will load the content for checkout for it. But this next one was run a little bit later. And by the dynamic nature of search results, the top items re-ranked in between tests. So this is supposed to be a GIF. Well, just pretend it's clicking into the screen. The new product here is a Pixel 6 Pro, like the actual phone, instead of the phone case. Nothing changed about our test that we wrote, just the fact that the top item is now a real phone rather than the phone case itself. And What you unfortunately can't see in this slide that the GIF would show is that the request for the Pixel 6 Pro was about a second longer. And so this contains an element of non-determinism. Like, we cannot directly control what products appear in our search results and what the order of products might appear in. So this is not necessarily the best candidate for a performance test, or at least not the best candidate without workarounds. There are ways to work around it, of course. Like, we could launch into this specific product using a deep link, or we might be able to mock the network request to return the same search results every time when we click into it. But that's assuming that we already have built something else into the system to support that, being deep links or a system to network mock, which we as developers might not have. And so all I wanted to do was test to see that we could click an item and how fast the buy now screen showed up. And now if I had to build a deep link system, or if I had to mock network requests to support this, that's exploded the scope of my performance testing. And your time as a developer is limited. And so, like we talked about earlier, testing every single micro interaction or every single flow in your application is not necessarily practical. It would be a losing game to chase the performance of every single thing in your app. Let's say we wanted to test the time it took for a user to click the details screen on this video. How impactful is it if a user's tap on expanding the description of a video is just a slight amount slower? Would the user even notice, given that the video is likely playing at the same time that they click on that? Some measurements are already masked or hidden from the user, or just not that important, that if we were trying to test for everything in our app, we might build performance tests that don't end up actually tracking anything meaningful. So now that we've introduced this criteria, let's use it to filter out some actual example measurements that we want to avoid in performance testing. Let's avoid testing non-controllable interactions without at least mocking or workarounds. Network operations or things like communication with other app processes might be something that's out of our control that we don't want to test. We also want to avoid non-reproducible things like content that is dynamic or changing depending on the state of the backend. And finally, in a perfect world, we test just about everything we could, but we're limited by time and resources in an organization. So we want to avoid testing non-impactful metrics. And examples of things that might not be that impactful are usually driven by your app's business case. And are unique to each app, but a good way to look at it is things that aren't necessarily primary user flows, or things that might be masked by other interactions that are occurring at the same time. So in the case of that YouTube example, a video is playing and someone clicks the details loading might not be that impactful because it's masked by the YouTube video that's actually playing. So let's move on into the implementation of what we just covered. We'll take a glance at some strategies and tools at our disposal that we can use to accurately measure and test our app's performance. And so in the past few years, we've seen an explosion in a ton of high-quality measurement tools available on Android. And I like to separate the tools into two primary buckets when it comes to performance testing. Those for measuring and those for testing. And I'm going to get a little bit opinionated today from my personal experience working on a lot of these tools to give you guys some guidance on what are most useful as it pertains. There are definitely much more than this list, just to be clear. This narrows down from a lot of my personal experience and what we've used at my company when running around with many other tools and experimenting with things. And so I'm even going to cross out two more from this list for specific reasons. So as for the Android Studio Profiler, it's primarily for one-off local tests. And it even uses a tool under the hood, SimplePerf, that we'll actually get into in a little while. On the testing side, I've knocked off Espresso. It's not a viable candidate for performance testing, unfortunately, as it actually attaches itself to the app's process, which can significantly affect the actual performance of the app that we're targeting. And so let's first look at the tools that we can use to measure performance and how those influence what we might test. So before talking about measuring and the tools that we use to do it, it's good to briefly touch on the idea of comparing performance results. The whole purpose of performance testing in CI is to try and catch regressions or improvements, hopefully, before they can make it into production. And the only way that that can be done is by comparing results. No matter the way that we choose to measure performance, we need to have a control and experiment version that we're comparing. The controller experiment can be as easy as the release over a release, so version 1 versus version 2. Or if we want to do even more, we could do every single commit on a PR against the main branch. We'll get into the cadence of performance testing in a little while. Second, it's important to use relative comparisons, such as a percentage change, rather than absolute changes like milliseconds. So let's say that we chose to test on a flagship device, like a Pixel 6 Pro, and we detect a change. A Pixel 6 Pro could have wildly different performance measurements of your test than something like a Samsung Galaxy S5. There's a good chance that you'll still be able to see a change in the performance on a Pixel 6 Pro, but it might be significantly smaller than the change that you would see on a different device. And so differences between measurements should be calculated as a relative change or a percentage to give a relative idea of the impact the change might have, rather than something that's absolute and established across all devices. And finally, we'll touch on this shortly, but by collecting and comparing sampling data, like flame graphs, that allows us to attribute change to specific functions that might occur during a performance measurement, which will give us the most actionable results afterwards to fix and improve performance. And so the first measurement tool I'd like to talk about today is Perfetto. In my opinion, Perfetto is the most powerful tool as it comes to mobile performance measurement. How many people in here have used or tried out Perfetto before? I'd like to see a fair amount of hands, that's good. If you've used Perfetto, you might see this the first time you use it. And this is quite scary. It throws a ton of things at you. This was just a simple recording that I took of that same Hacker News startup that I showed you guys earlier. And so we're getting CPU frequencies, we're getting GPU frequencies, we're getting lots of things that I might not necessarily care about if I'm just trying to detect a regression in my startup flow. Under the hood, Perfetto leverages internal Android and Linux perf testing tools. It also provides quite a few additional tools like the web UI that you guys see right here for visualizing the traces that you see. But nonetheless, it produced an incredibly detailed amount of data and allows us to analyze just about every single thing that was occurring on our device while our app was running. I won't discuss what Perfetto records and like how to read the data in detail. There's a ton of different resources out there and even some talks from DroidCon that I've seen before that dive into how to parse a Perfetto trace. But the thing that I really want to hone in on is the SQL layer of Perfetto that some people might actually not know much about. And in my opinion, this is where Perfetto really, really shines. We can actually query pretty much all the data that we just saw from the last slide using SQL statements. And so a simple example here shows us querying a few slices, as Perfetto calls it, from a Perfetto trace. And in this case, we're querying like a zygote init, which is just the process start, or a bind application, which is what occurs during your application on create. And so it's just a super simple SQL statement, and it produces, basically takes what we see on the top over here, the differing time, like this would be in order of how it started, so your process started, the application was bound, and your first frame was rendered. And it gives us it as a table, returning things like timestamp, name, and the duration of those spans. And so Microbenchmark actually even leverages the SQL ability under the hood and gives us the ability to use the results of this to actually calculate different metrics that we want to. So we can just take the timestamps of it, the durations, add those up, and it will give us a consistent measure for something like startup time or any other metric that we might want to test in our apps. And so using the power of Perfetto, we can easily profile and trace our application without running directly in the target apps process and affect performance. And then post-process the result after the fact using SQL statements against that Perfetto trace without ever having to view a UI like I showed you guys before. So some pros and cons of Perfetto before we move on, just to sum everything up, is that Perfetto really, really shines when it leverages its SQL layer. Almost all the data that Perfetto records is exposed to SQL tables. There's a lot of documentation on the Perfetto site about these tables, the structure of them, how to query them, things like that, which allows us to build very rich queries to pull the data that we're interested in processing out from the tables themselves. Perfetto is also very well documented, and it's maintained by Google. In addition, Perfetto running against your app has little to no performance impact of the app itself. It relies on tracing, not sampling. So if it's not much of a concern when we're measuring the performance of our target application. Perfetto does have a few cons, though. It's worth noting that, like I mentioned, Perfetto is really used for tracing, but Perfetto can actually sample too. You have to modify some of the configuration of Perfetto, and just to be clear too, tracing is measuring spans of things that occur in your app. Sampling is actually looking at the call stack of every function that's being called in your app at a certain frequency. And so Perfetto can do both, but the support for sampling in Perfetto is missing a lot of critical functionality. There's some open issues too in the Perfetto repository and on like Google's issue tracker that have just been kind of stagnant for a few years, and so I'll get into a tool in a minute that can help us work around some of that. And finally, Perfetto has a high learning curve. By the screenshot that I showed you earlier, it's quite daunting when you first view a Perfetto trace, simply due to the sheer amount of data that's being thrown at you. But if you kind of take it in bite-sized pieces using the SQL functionality, it makes it a lot easier to process what's actually going on. So Perfetto is a great tool for collecting traces and their durations, but tracing is only part of the performance battle. If we want to get an even deeper look into what's going on in our apps, we can also sample the methods that are occurring during the execution of our test. Has anyone used SimplePerf in here before? I expected to see less hands for that one. SimplePerf is a tool that the Android Studio Profiler actually leverages to sample apps. So if you've ever used Android Studio Profiling, you might see a flame graph or a bunch of different performance metrics that are recorded. A lot of that actually comes directly from SimplePerf itself. And SimplePerf is just a binary that's created from a C++ project that you can execute on device, you can execute on a bunch of different machines. And while Perfetto traces, SimplePerf samples. And so in my opinion, combining the two, we can get slices from Perfetto with timestamps and actually trim the samples from SimplePerf to give us an all-encompassing view of our app's performance. So how can we actually use SimplePerf to give us a full picture? And so SimplePerf actually offers a ton of tools built into it. Things like scripts to generate Brendan Gregg's folded format, if you guys have ever heard this, kind of the industry standard for flame graphs, or even Firefox Gecko profilers, which you can view through the Firefox profiler. Sampling, of course, does have a small performance hit, but this performance hit is one that's relatively minimal and can be mitigated by adjusting the SimplePerf parameters. And so for actionable results, I highly recommend doing some sort of sampling as well in your app, because what tracing does well is it gives us the overall spans of what was occurring in our app, but what sampling does even better is actually tells us what is being called inside of our app. And so sampling will give you a picture of durations, tracing will give you durations. Sampling will tell you literally what functions were called and the order in which they were called. So we read this basically from top to bottom, that things were called into other ones, and we can see the full duration of those specific functions. And in my opinion, for being able to root cause specific performance regressions, seeing the actual functions and how they might be in code is the most important thing for identifying how to fix those performance regressions or where they came from in the first place. And so these flame graphs can be further transformed to produce something that's called a differential flame graph, which provides a visual representation for the difference between two flame graphs. And this is personally where I think the biggest power of flame graphs comes from. We can actually diff them to build a coloring scheme that reflects changes in specific function calls. I won't explain necessarily how to generate these. Brendan Gregg, the creator of flame graphs in the first place, has a ton of resources on his website that I would highly recommend checking out on how to actually create diff flame graphs. But essentially, diff flame graphs can give us the most insight into what is actually occurring in our app that regressed or hopefully actually improved. So hopefully you would see more green in the screenshot in production. So to sum things up for SimplePerf, let's go through some pros and cons just like we did with Perfetto. For the pros, SimplePerf samples the methods that that are occurring during the sample period. And it gives us the best view or the most detailed view of everything that's occurring in our app. It also comes with a ton of helper scripts that enable us to convert the raw output of SimplePerf into something that's more usable, like the Brendan Gregg folded format that I talked about, or Gecko profiles that can be viewed in the Firefox profiler. I personally use Brendan Gregg's folded formats. I think that it's a universal format that can be transformed into a bunch of different things, and there's a bunch of tooling out there to support those formats. Finally, the helper scripts also handle deobfuscation, so anything like reversing ProGuard mappings or DexGuard or anything that you guys might use. And then other lower level things like symbol allocation and demangling it does for us, which is super nice if you've ever had to deal with that stuff before. But On the downside, SimplePerf is a sampler, and so being sampling, it basically takes a snapshot every certain, it depends on your sampling frequency, which you can specify, but it takes a snapshot of the call stack at any given time, and that is a non-trivial amount of work that's occurring. And so that can actually influence your performance results, but you do have that sampling frequency at your disposal to determine how often we take that snapshot, and you can adjust that to make sure it doesn't affect performance too much. SimplePerf is also, unfortunately, pretty poorly documented. Just by the judge of hands in here too, I already saw that a lot of people have not used SimplePerf before, which tells me a lot already, compared to the people who have used Perfetto before. And so unfortunately, it's not the best documented, and much of my personal experience that I'm sharing with you today has come from trial and error, just playing around with it. And finally, going on with the poor documentation, configuring and running SimplePerf is a bit cumbersome, and much of the parameters are hidden, especially if you're not on like a rooted device or something that gives system level permissions. It's still very much possible on non-rooted devices, but there are a ton of like workarounds that you might have to go about to get it to work reliably. I've even had to dive into the actual C++ like implementation of it to be able to find out about the different configuration options at our disposal. So overall for measurement, I personally use a combination of both of those. I use SimplePerf and I use Perfetto to give me the best snapshot of everything when it comes to performance testing, combining those SQL statements that we use to get the different spans that are occurring in our app, and then using SimplePerf to give us the deep dive into what is specifically changing. But measurement is only half the game. So how should we actually run tests to test our performance without affecting the performance of the app itself? And I want to touch on the most difficult problem to solve pertaining perf testing, and that's variance. You could run startup for your app right now, and then 15 minutes later I can move across the room and potentially get wildly different results. And that's all because of different things like thermal factors, thermal state, CPU clocks, memory state, etc. And when you add that to the performance testing mix, variance can prevent us from getting accurate results. And so to mitigate this problem in performance testing, we need to try and control as much of this as possible. And there's two primary ways that we can do that. We can mitigate variance by obtaining a large sample size, which will allow us to trim the outliers and to basically leverage the scale of data to try and give us the biggest picture of our data as possible. The second is to control as much as possible about a run. So you can lock clocks, you can clear the page cache, you can mock network requests, and so much more. And this will ensure the state of the device and the app is always as similar as possible across runs, giving results that aren't prone to like other factors outside of our control affecting the results. And so our first tool that I'd like to discuss is Microbenchmark. How many people have tried or used Microbenchmark in here? Good, great. I like to see a lot of hands for that one. A lot of people might have used Microbenchmark for baseline profiles, but it is also a very, very good benchmarking tool. And so it's a library created by Google, as many of you guys know, that allows for benchmarking performance metrics at scale. And so a quick sample above shows how easy it is to configure a full startup test. Being able to configure things like iteration, startup mode, the actual app we're targeting, and the different metrics that we want to pull out from it. And so, yeah, many people might have used this already, and especially for generating baseline profiles. I'm not going to touch on baseline profiles today. That's worth exploring as well, but a bit out of the scope of performance testing. And so Microbenchmark leverages that SQL layer of Perfetto under the hood that I mentioned to you guys earlier. And that's how it gathers performance data when it profiles your app. So to control variance, Microbenchmark also leverages a separate test app that's running against your app and to separate the performance benchmarking out of the app's process itself, ensuring that it won't affect performance measures. Microbenchmark helps to get performance benchmarks running as fast as possible, providing tons of functionality behind the scenes to make controlling our testing much more accurate without much work on our part to get it going. Microbenchmark also outputs results in JSON, and it even gives you the Perfetto trace that it recorded. So you can do a lot of custom post-processing work on it using that SQL layer that I told you earlier. But with all the freebies Microbenchmark does give us, it gets a bit restrictive at times, especially if we need more customization or need to control what Perfetto is actually recording, which is where UI Automator comes in, which I'll get into in a minute. But like other tools, I'm going to hit on some pros and cons of Microbenchmark first. And firstly, we'll hit on the pros. As we've shown, Microbenchmark is an incredibly simple implementation and by far the fastest way to get going when doing performance testing. It provides a ton of freebies, manages variance for you behind the scenes, and you really don't have to worry about too much other than the simple parameters that you can control going into it. Much of the complicated aspects are abstracted away, like running multiple iterations, allowing you easy control of everything that's going on. But it brings some cons too, of course. And it's inflexible to bigger demands, and like I talked about, it controls the Perfetto configuration under the hood, and it doesn't allow us to specify additional things that we might want to query from those or gather for those Perfetto traces. It also controls variance, but to a point. It automatically does things like ahead of time compile your app depending on the settings you set, and even like querying the page cache or setting other performance modes on your device. But if you need to do additional variance control methods, like setting specific CPU clock speeds and deeper level variance control, you'll have to add additional configuration on your own. And finally, Microbenchmark doesn't provide sampling built in to generate flame graphs like we talked about it earlier. The benchmark library does have a simple perf profiler built into it that you should theoretically be able to leverage, but I've never personally actually been able to get it working. I've had to run simple perf on my own, and so since it prevents you from being able to sample, we only get a one side of the picture of our performance, which is a big disadvantage for me personally. And the final testing tool that I want to touch on is UI Automator. And UI Automator is a framework introduced by Google that is an absolute must for performance testing, and it is actually leveraged, like I mentioned, by Microbenchmark. Other test methods, like we talked about briefly, such as Espresso, attach themselves directly to the app's process when it's running. And by doing so, the testing framework itself might actually affect the performance of the app that you're trying to test. UI Automator doesn't have to rely on the app's process itself. It can run as a standard like UI test, but there's an idea of a self-instrumenting test that has come out more recently where you can create a test APK that's running in a separate process, and UI Automator can actually execute different actions against your app. UI Automator isn't a performance benchmarking tool, just to be clear. It can be combined, though, with all the measurement tools we talked about earlier, like Perfetto and Simple Perf, to give us more control over what Perfetto or Simple Perf are recording. And usually Microbenchmark will cover most of our performance benchmarking cases, but if you need to go deeper and you really want that like deep level flame graph view or something more from Perfetto that you can't get from Microbenchmark, you'll have to leverage UI Automator for your UI testing needs. And so for a quick summary of UI Automator, it gives you the most flexibility to control device state, iterations, what's occurring in an actual test, and the measurements of those tests. And just like Microbenchmark, it can be run separate from the app's target process, which won't affect our app's performance, which is the most important thing for performance testing. And it can still leverage many of the elements of the Microbenchmark libraries, which you can still import and use yourself directly in your tests to control variance, even use some of the helper functions that Microbenchmark provides to run iterations and things like that. As for cons, of course, doing everything manually where it gives you full control, it also requires that you have full control. And so it's a significantly higher amount of work to get things working. And that brings a maintenance burden as well, having to update your tests afterwards. You also have to manually run all measurement tools and leverage those after the fact to post-process, but I personally, in my work, lean to a more custom implementation using UI Automator and the other tools that we talk about. As in my personal experience, Microbenchmark is awesome for getting off the ground, getting running, especially things for like baseline profiles, if that's what you're more interested in. But as soon as you need to do anything more custom than the basics, like additional variance control, custom measurements, custom metrics that you want to record from Perfetto, it's very inflexible for change at that point. And so a custom solution becomes the obvious path forward. So we talked about different methods that we have at our disposal for measuring and testing performance, which in my opinion is actually the easy part of performance testing. Now let's get into what I actually think that the hardest part of performance testing is, and that's scaling performance tests across an entire organization so that we can catch issues and suggest improvements at scale. So as with performance testing and measuring, I'll get into some high-level strategies that you can use to run perf tests for your org. But before that, I want to talk to a general concept that I've seen in my experience, and that there's 3 primary trade-offs at hand when you scale performance testing. Cost being a financial cost, accuracy, and speed. Let's break these down a little bit more. So there's a lot of levers that you can pull and adjust to fit your team and organization's needs. The type of device that you choose will significantly affect the cost that it takes to run performance tests, and the accuracy of them too. So testing, like we mentioned earlier, on the latest and greatest Pixel 6 might give you reliable results, but might not represent the diverse spread of devices your users use and could be too fast to catch small regressions. Choosing to run on a physical device rather than like an emulator might also affect cost and accuracy, as well as how you orchestrate those tests. The cadence that you run performance tests and the scale at which you run them also will influence the number of devices that you might need, which influences cost. If you choose to run on every single commit, and you have 100 engineers in your organization, you're going to need a lot of devices or a lot of emulators and an orchestration system to make sure that you're running on the right device at the right time. Alternatively, if you choose to just compare release over release, this can be done on a more manual cadence or might just require 1 or 2 devices or something like that. But pinpointing the changes that caused a perf regression might be significantly more difficult to do. You can also choose the number of iterations you run per test, which will make performance tests faster, but with less data, of course, comes more noisy data. So that prevents us from being able to filter out things like outliers, which can affect your overall performance benchmarks. And as you can see, there's just a lot of different levers, even more than what I just mentioned, that we can use to control our performance testing configuration. Each has some sort of trade-off that we might have to accept as a consequence of our decision. And last but not least, we've established how to measure tests and some strategies for the different levers we can pull to scale. But how do we actually deliver actionable results that we can quickly address and fix the issue? The first aspect of delivering results is pinpointing the source of the change. Running perf tests at a PR level makes it really easy for us to identify the sources of change for any macro benchmarks, and oftentimes make finding the source of perf changes the easiest by simply looking at the diff. Sampling all of the methods during a perf test is the most detailed strategy we can apply and allows us to create flame graphs, which we confront directly, like in the pull request itself, to say that a function or a regression was detected, here's where it actually was, and show the flame graph of the performance test. I won't get too in depth on how to actually front things in like a PR, because that's widely dependent on GitHub, GitLab, things like that. But I would highly suggest that sort of cadence being like the pull request cadence, because it allows the most targeted way to actually record performance changes. And so I went over a lot today. And if you guys learned anything, it's that performance testing is probably quite difficult, and that there's a ton of different things going on, a ton of different levers that you guys can control to affect it. And so I just want to sum everything up real quick just to make sure we hit on all the high levels. So the first step is determining what you will test and why. We should follow our framework introduced earlier when determining what are good candidates for perf testing. And these metrics should be controllable, reproducible, and impactful. The second step is determining how we will test those metrics. So we went over lots of tools at our disposal, like Perfetto, Simple Perf, Microbenchmark, UI Automator. And finally, we went over the probably more difficult part of perf testing, which is scaling perf tests across an org. We went over all the perf testing trade-offs, how cost, accuracy, and speed are the 3 most determining factors when running perf tests at scale, and how we can adjust those to fit our needs. And finally, it should be somewhat obvious, but performance testing is quite hard, and much of my experience has come from my company, Emerge Tools. We have quite a few solutions that can make perf testing quite a bit easier for you and your organization. So if you're interested in learning more, just let me know. And with that, that concludes my talk. I'd like to thank everyone for attending. And with that too, feel free to email me at any point. I'm more than happy to discuss performance testing with you guys. Follow me on Twitter, and I can open the floor to any questions that people might have.